3, 4, 5. All right, we got everybody here. All right, so, all right, let's talk through this and see. Before somebody would put in, so this is the thing, if you really would like your coffee to last a really long time in your insulated mug, this is a step that you can do. Before you have, if you have your mug at room temperature, that means your mug has low thermal energy, correct? And when you pour hot coffee in it, the hot coffee is high thermal energy. Which direction does energy always go? It goes from high to low. So as soon as you pour that coffee in there, it's going to start to lose energy to its surroundings, including the mug. Now, the mug is an insulator, okay? So it will do so slowly, but it's still going to lose energy. If you were, though, to take some hot tap water and put it in there first and let it sit there while you were making your coffee, it's going to change the walls of the mug from low to what? You're now going to give it additional energy. We're going to give the mug itself. Maybe I redo this. Okay. You're going to give the mug itself some energy. You're going to pre-warm it basically. The mug is now going to be high because the mug's going to be hot. When you pour the coffee in, it's also going to be high. And that's going to keep your coffee warmer for longer because you're going to have less energy transfer. Because when you pour that sucker into a cold cup, it's immediately going to start to lose energy. But if you preheat that mug, okay, you're doing good. So the main thing I just want you to always think about, like we talked about when you step on the tile versus when you step on the rug, which direction is energy flowing, all that kind of good stuff. You know, everything always goes from high to low, okay? So just wanted to throw one back at you to make sure you didn't remember. You'll have to know this stuff by the test on next Friday, the 13th, okay? All right, so that was not the hard stuff. That is actually quite easy, but that was from the beginning of the unit. Okay. All right. So let's get into some serious hard stuff. This math. I'm not going to do this again for you. Okay. Lab wise, I think you just need some time to crunch some calculations. I'm going to do the first one with you. I'm going to have you do the second one by yourself. And then there is a practice one on Schoology. Okay. So let's read through. This here says, I would like for you to calculate the specific heat capacity of 20 pennies. Okay. You have your standard apparatus, 20 pennies, electronic balance, styrofoam cups, thermometer, and tap water. Prepare the hot water bath to heat the pennies. So what they were saying is that you took pennies and you put it in a hot water bath. This is boiling. What temperature is this water going to be at if it's boiling? 100 degrees, right? Perfect. So boiling bath, it boils at 100 degrees. You want to write that down. The pennies are going to be boiled for 5 minutes. Now, let's take a look at what we have in our data table, because this is exactly what you're going to see on Friday. You have the mass of your empty cups. Okay, so that would be like me putting this on here. Beautiful. Then you have, when the person adds 60 milliliters of water to that, okay, now you have the mass of the cups with the water. Is this the mass of just the water? No, it is not. So always, what are you going to do with these two numbers to fill in this blank? You're going to subtract. So we'll grab our calculator. We're going to say 68.35 minus 9.25. Enter 59.10 grams. Does everybody see how I got that? Yes. Filling it in. 59.1. That's because we subtracted these. Then it said, took the mass of the pennies. You might want to write above. So this is my MH2O, mass of the water. This is my M pennies. And then the initial tap water was 19.9 degrees Celsius. And when you take rockin' hot pennies and you chuck it in here, if you have hot pennies going into cold water, what's going to happen to the temperature of the cold water? It's going to go up. And where it went up to was 25.8. So you will get this data on your quiz on Friday, okay? Then what you're going to do is you're going to proceed and fill out the rest of the stuff. So I'm going to do one with you, you're going to do one by yourself, and you're going to do one online. So again, the initial metal temperature. Why was it boiled for 5 minutes? Because it needed to reach what temperature? 100. So you'll fill this in. And the metals are always going to start at 100 because that's why you're boiling the metals whenever you do any of these labs. Now it says initial water temperature. You just have to learn how to bring your information down. The initial water temperature, it's all written right here. I can see it's written initial temperature of the water was 19.9. And what did they meet at? 25.8. So my water went from 19.9 to 25.8, and my metal went from 100 to 25.8. What do you do with these numbers to find the delta T? You subtract, okay? If it went 19 to 25 and 100 to 25, and if you accidentally put them in the wrong order and you get a negative, it is fine. Just don't worry about the negative. Just give me the regular number. So I'm going to do 100 minus 25.8. Let me do 8, not 2. 74.2. Everybody with me on that one? Feeling good? Then if it warmed up from 90, let's say you were 199 pounds and now you're 250.8 pounds, how do you know how much you changed? You would just take the difference. So 25.8 minus 19.9. You went up 5.9 degrees. Does everybody agree with those two items? You're going to have to be able to do this by yourself. Awesome.
Wait, how did you get the change tap water?
Yep. The tap water went from the initial 19.9 to 25. If that's how many degrees it warmed up, mathematically, how would you tell me how many that was? Subtract. Subtract this, subtract that. Delta T means subtract. Okay? Perfect. So we're here. The other thing you'll see that for some reason students just don't look at, specific heat capacity of water is here. What value is that? Is that Q, M, C, or delta T? Specific heat capacity is C. So that's also going to be on your paper. Okay? Now we have all the information we need in order to do the math. Remember, any energy gained by the tap water. That means whatever made the tap water hot is exactly the same amount of energy lost by the penny. So I can set up a Q to Q. Q is equal to MC delta T, MC delta T, and these are going to be equal to each other. Okay, let's fill it in. What is the M of my tap water? You have to look up here. The mass of my tap water is 59.1. The C for water is 4.18. The delta T for my tap water, if you fill this in up here, you know exactly what you're doing. 5.9. The M for my penny is 49.5. I'm looking for, that's the question, what is the C value of the penny? And my penny went from 100 to 25.8, so that's 74.2. Okay, does anybody see where or why we put any of these numbers where they go? Now let's algebraically solve for C. 59.1 times 4.18 times 5.9. It's going to be a pretty big number. Okay, you're looking at 1457.52. 1,457.52. Then on this side, we multiply together and we leave C there. 49.5 times 74.2, 3,672.9. Okay.
Wait, so how do we find those numbers?
Multiply. These are multiplication. Multiply, multiply, and this is a equal sign. So you multiply this whole side to give you this, and you multiply this whole side to give you this, okay? But we still have the C value here. Now, if I told you 4 is equal to 2x, how would you solve for x? Divide both sides by 2, right? You're doing the same thing. This is equal to this C. So in order to get C by itself, I'm going to divide everything by 3672.9. Okay, that's going to get C by itself. So now I'm going to take my calculator. I'm going to write 1457.52 divided by 3672.9 equals, and now we can round it. I'm going to give you a odd number here, 0.397, if you will. Now remember, what is the unit for specific heat capacity? It's the wonky one. You do have to know it on the quiz. That's joules per gram degree Celsius. Okay? So what you're finding is the C value, how much energy it takes to heat each gram 1 degree Celsius of an unknown metal or your pennies. Okay? So what we're going to do today, and everybody has this at home, we have one more. It's the exact same process. It says determine the specific heat capacity of a nail. So what you're going to do is you're going to do this one on paper. Okay? Go through. The answer key is in the Wednesday folder. I'm going to walk around here. I'm also going to talk to you guys online, see how you guys are doing. Okay, but I want you guys to now do this on your own. Then, just so you know, because this is going to be really challenging, and let me show you what this looks like, because I didn't know the best way to do this. So, and before you get started here, eyes up here so I can tell you. After you do the one on paper, you're going to go into week 11. That's the week we're in. And you're going to go into the Wednesday folder. Okay? You can go ahead and do your participation points. Awesome. Then you see right here where it says practice quiz. I highly suggest, it's not worth credit. It won't help you, won't hurt you. But I suggest you go in because this is tough because your quiz question looks like this. Okay? It is the exact same thing. I just put a whole bunch of numbers down here for you to choose from. So you'll do the math like you would on a piece of paper, and you would just drag up, that must be 27. This one must be 59. This one. And so you have all of the numbers, okay? So do one on paper, which you have, and I can help you. Okay. And then also do this practice quiz in week 11. So that's what you have to do for the rest of the period, which is about 20, 25 minutes. Okay, and if you want to see the key is right here on the Wednesday folder. But I suggest only checking it once you're done. Okay, so go through and tell me what is the specific heat capacity of this nail if the same thing happened. It was boiled for 5 minutes, then it was chucked into some water. You have to figure out how much water. You have to figure out the temperatures all the way down to the C value, but it's the same thing. So you should be feeling good. I'm going to come around and check in with everybody, and I'm checking in with everybody at home too as well. Everybody at home, you're doing this worksheet right now. All right. When I come around, if you can get started, say, leave me alone, I can get started. But if you need help starting, you are on your way. You know what? So the first thing I would do is figure out how much tap water is in those cups. If this is the empty cups, and this is the cups with the tap water in it, what do you think you do with those numbers in order to figure out how much mass is in there?
Would you minus it?
You're going to subtract. Good. Subtract those. That's going to get you here. Okay. Then you come down here, and you have your initial tap water temperature. You have your final temperature. The only thing that's you got to kind of remember is why do we boil that bolt? What temperature we're trying to get that bolt to?
100.
You got it. And when you're doing a delta T, you also subtract. And this is not letting me write, so that's fun. And then you're just going to go in, and if you can see all the data you have is going to be up here. You just have to plug it in and then solve for C, okay? I'll come back if you have any questions, okay?
Thank you.
You're doing great. You're on your way. We're at about 10 minutes remaining. Did you get that right there? Over there. All right. So hopefully everybody got about 0.12 joules per gram degree Celsius. If you didn't look at the key yet, here are your answers you should have gotten. Okay. The number one question I'm kind of getting here, which is it's easy to get confused. How do I go from here? I take this number has X on its side, so I'm going to divide the 299.25 by the 2000, so 299.25 divided by 2578.95. Okay, and then that gets you this number here. So now my suggestion, in the last 10 minutes of class, and I can come around and see if anybody has any questions at home, okay, determine the specific heat capacity of a metal practice quiz, click into it, and I suggest you take your packet, okay, I suggest you take your packet and don't use it, because on your quiz, you will not have it, but it's one more exactly the same problem, and you're just going to drag the numbers up into it. So have your calculator, see if you can do it on your own, but this is what your quiz will look like on Friday, okay? Good luck. Let's see if you can do it. Anybody at home have any questions that I can answer now that you got to practice at it? I'm going to see if I can show the right answers to this.